So expansion and compression of the graphs happen through the vertical expansion factor on the outside and the vertical expansion compression factor on the inside here. Okay, so these are multiplying factors. So multiplication is an expansion and compression along the number line. So the A coefficient is going to expand vertically, and for the outside y always happens the way that it's written. So if it says times by 3, it's going to expand by 3. If it says divide by 3, it's going to compress by 3. Okay, so the greater the value, the greater the vertical expansion. The B coefficient, on the other hand, compresses and expands horizontally, but it happens in the reverse. So the bigger the B value is, the more it compresses. The smaller the B is, the more it expands. Okay, so if it's bigger than 1, it will compress. If it's smaller than 1 or divide, it will expand. It does the opposite. Okay, and we know that all the x's happen in the opposite. So when we have this sine graph here, so this is a graph of sine. Okay, we have a period of 0 to 360 degrees, or 0 to 2 pi. So this graph has one full cycle in 360 degrees. Now, if we multiply the angles by 2, well, we only need 180 degrees inside to be able to go through the full cycle of sine. So what ends up happening then is we end up with a horizontal compression. So that times 2 allows this to compress to 180 degrees here. Okay, whereas normally it would go to 360 degrees. So we end up with a horizontal compression. So the times 2 makes you go through the angles faster, which results in a compression. Here, the 1 over 9, this ends up being a horizontal expansion, because what ends up happening is we end up needing bigger x's to get the same y value. So these bigger x's get stretched out horizontally. So this represents a 9 times expansion. So the first one here, sine, this times 2 here represents a compression, okay, of 1/2. So that's a compression of 1/2. This ends up being an expansion of 9 times. So divide by 9 really means times by 9. Times by 2 really means divide by 2. It's the opposite. Okay, so this is not uncharacteristic of what we've been seeing already. All the x's were opposites. Now, just looking at this graph here though, it does look like it's possible that it got compressed vertically. So here's my, it almost looks like we could have, definitely we stretched it horizontally here, but this graph could possibly be described, maybe described as a vertical compression. And in fact, it is quite possible that we can rewrite this. And we can rewrite this algebraically as 1/3 on the outside square root x. Sometimes algebraically, these factors can be expressed both inside like here and outside here. Well, if it's expressed on the outside, this is actually a vertical compression of 3. So if we took a coordinate here of 9 over 3 up, it gets compressed 3 times to that point there. And in fact, that's true. That point is a vertical compression of 1/3. Okay? And so it is possible to describe it both ways. It is in both a horizontal expansion by 9, it got stretched this way, but if we factor that out and take it on the outside and express it on the outside of the function, it can be thought of as a vertical compression of 3. Now, this is only if the algebra permits it. In this case here, there is no vertical change here of the y coordinates because there's no way that 2 can be expressed on the outside of the sine. So thus, in this case here, it can only be expressed as a horizontal compression. Here, this is a horizontal expansion, which algebraically can be expressed as 1/3 on the outside. Outside means it's a vertical transformation.